And that's really critical. All right, we are ready to start here. Look at that timer. Stream begins now. Ladies and gentlemen, the timer actually worked. All right, so I wasn't that sick last night, I guess. Ladies and gentlemen, thank you for joining me. Welcome to day 3 of Handmade Hero. I am a little bit sick and I apologize, but I have some cough drops here, so I am going to try to get by. We'll see if I don't need them, I won't use them because I'm afraid they might make some weird sounds with the microphone, but we'll see what we can do. All right, let's get started. If you remember from last time, we were at the point where we had just gotten a Win32 window up, but we had not really finished our application. And so there's some things that we have to tidy up first, and then we need to start drawing to our window the way that we actually want to start developing our own renderer, meaning something that will allow us to make our own buffer of pixels that we can write, basically our renderer any way that we want to work on, and then we need to basically give that to Windows so that it will display it in our window for us. And this won't necessarily be the most efficient way to render things on Windows, because nowadays everything goes through the 3D graphics card. But before we ever do anything involving the 3D graphics card or any of that stuff, like I said, I want to show you how to write everything from scratch yourself. And so what we're going to do first is we're going to use a slightly slower method, which is we're going to do all the rendering ourselves, and then we're going to blit it to the screen. Okay, so this is sort of, in some sense, going back to the old days when this was actually how you had to write a renderer, because there really wasn't much in the way the graphics card could do for you. You wrote everything yourself to a buffer, and then you just told the graphics card, hey, this is the buffer that you need to display. And so that's basically what we're doing, and that's the first step in learning how a renderer works. Here we go. I'm going to open up Emacs. And by the way, I should say this, I hadn't said it yet in the stream, but if you are someone who has gone to the website and has pre-ordered the game, then you will actually have a zip file that looks something like, where are they here? Something like this. Basically, you will have a zip file that's got this stuff in it here. And what you want to do is you want to look inside your zip file, and there'll be day numbers, day 01, day 002, and so on. So if you are watching this video again sometime in the future, you will want to grab day 2, which is the day before this, unzip that, and that is the version of the source that we are starting with. So to make sure everyone's in sync, please make sure you do that before trying to follow what's going on here, because otherwise your source code will be out of date. So we've got one source file so far. It's win32handmade.cpp, and this right here is our window callback. Now you'll remember what we did last time was we made a little message loop here, and Windows basically has a message queue for our application that it stuffs things in, and we have to pull them out one at a time, translate them and dispatch them, and then we will get them in our window callback. Now, we also talked a little bit in the Q&A, I believe, about why we have to have a callback at all, because if we're the people who are pulling the messages off the queue down here, well, why can't we just call whatever function we want? And the reason, as we saw in the Q&A, is because Windows reserves the right to call us back at that window callback anytime it wants to. It does not have to do it inside this dispatch message. That's the sort of mental model that they were going for, is that they call us back inside dispatch message. But, of course, Windows, things get crazy, so they started having places where it calls us out of the middle of nowhere. So anytime we call into a Windows function, no matter what it is, we kind of have to be ready for it to potentially call us back in there. Okay, so what we did and where we left off is something that is not really sufficient for our purposes. Basically, we had two things that we had to fix. One is that you'll notice, and those of you who tried at home, I'm going to go ahead and launch the debugger here so we can take a look at our program. So for those of you who are following along at home, you know that when you run this application, you end up in a circumstance where there is really nothing you can do with it. You cannot close it. I mean, you can resize it and see our black-white alternating pattern that we decided to have in there just to make sure things were working. You can do all that, but you cannot close the window. And so really there's no way to exit this application without going back to the debugger and hitting Shift F5, or going into debug here and hitting stop debugging. And that is because we are not yet handling the close message. Okay, so in order to handle the close message properly, there's a couple things that we have to do. The first thing is we want to go back here and take a look here at the loop that we created that's pulling these get messages off. Now, if you remember, if we go back to MSDN, And we looked at this the other day. But if we go back to MSDN, the documentation for getMessage is very explicit about what's going to happen when we call it. It says, in fact, it even gives some sample code down here. It basically says that there's a possibility of a return value of 0 if the WM quit message is posted, which is basically a way of Windows telling us that it wants our app to exit right away. But there's also the possibility of a -1, which means there was some kind of error in the get message and we should exit as well. So, given those two things, we checked for greater than 0. What that basically means is that if we want to exit this application at the moment, what we will have to do is basically get this thing to go ahead and get a WM quit message. And there's a really easy way that we can do that. We can actually tell Windows to just go ahead and post a quit message right on our queue. There you go. Now, if you take a look at post quit message in MSDN, again, always get used to MSDN. And by the way, I'll mention one other thing that someone wrote in and told me about that's pretty important. When you go to MSDN, we have not had this happen on the live stream, but somebody had it happen at home, where sometimes it'll come up with the documentation for Windows Mobile or something. And the reason that you care about that is because the documentation that we want has stuff like this in it, which says which version of the desktop Windows you want to use in order to support it, right? So we need to know that information, and we also need to know, sorry, I said that poorly. It says what the minimum supported desktop version is, so we know what our game can ship on minimally. So Windows 2000 Professional is the earliest thing we could ship on. No problem there. No one's using anything before XP these days. But you also have the library and the DLL name here, which we need to use to resolve unresolved symbols, and we saw that in the previous stream. So make sure you are actually looking at the desktop version of Windows, which should say here, if you're not seeing things like minimum supported client Windows 2000 Professional or some other desktop version, then you need to make sure that you can switch to that. And I think you use the desktop technologies here, develop desktop. I don't know. MSDN changes so frequently, it's hard to say. Hopefully sometime during the stream we'll have the mobile one come up and I can sort of fuss around with it and get us to the right place. But there you go. All right, so post quit message basically posts an exit code as part of the quit message, and the exit code is just something that if we were posting this quit message in some kind of an error situation, it's basically just a way that we can sneak a little numeric value into that quit message. And if you look at the quit message, WM quit, it's basically a thing here that just is opaque to us. But when we do that post quit message, we'll be able to get this exit code back out if we really wanted it. Now, we don't care about any of this stuff because we're a game, and games don't interact with Windows in hardly at all, basically. But if we did care, we would start to think about, oh, do we need to pass error codes back and all these sorts of things. We don't care about that at all. All we want to do is post a WM quit message in response to WM close so that we will fall out of this loop. Now, there's two things we could have done here. And I will show you how to do the second one as well, because it's probably a little more proper, even though, again, as a game, we don't really care. So let me compile that. Let's go ahead in here, and we'll go ahead and set a breakpoint on that line. Here's our Handmade Hero app. When I close it, you will notice we get this post quit message. And when I hit F10 to step over that, I'm going to set another breakpoint down here just so we can see. When I go ahead and step over that, it has now posted that WM quit in our queue. And what we will find is that eventually now we will actually get that WM quit message, so this message result will come back as false eventually. Now remember, there's other messages in this queue, so it won't come back right away, but after a while, when we hit F5, we will get into a situation that message result is in fact false or 0, and we hit our break. Break breaks us out of the infinite for loop, which is this guy right here, and it ends the program. Now you may be asking me, or ready to ask me, or if you are one of those people out there who is very, very C++ focused or object-oriented focused, you may be having a fit right now. And that is okay. I apologize for that. I hope that it does not cause you too much mental anguish. But you will be upset because you will note that I did not close my window. Now, one of the things that people like to do a lot in object-oriented programming languages is they like to make sure that they always have completely symmetric construction and destruction, or acquisition and release of their resources. And what that means is that every time you make something, such as create window EX, where we made a window, or register window class, where we registered a window class, you want to make sure that if there is some way to clean that up, that you do so. They do that even if there is no need to clean it up. Now, I would love to rag on people who do that. I'd love to say some disparaging things right now, but here's the honest truth. I was one of those people. I was one of those people for a good probably 3 years of my life, and I wrote code like that all the time. It's the only way I programmed. Everything was written exactly that way. Some people call it resource acquisition is initialization. Other people might just think of it as having everything wrapped in a class with a constructor and a destructor. There's a lot of different methodologies that sort of have this same thing at their core, but they all boil down to that same thing. And so they would never want me to do something like creating a window that I had no plans for destroying. But later on, as I programmed more and started to ship a lot more real-world applications and cared about performance a lot and cared about a lot of things that I didn't care about or know about during the times when I programmed like that, basically what I found is that that is a really bad way to program. And the reason is because it is almost always the case that things are better acquired and released in aggregate. And what that means is that instead of thinking about things individually, you always think of them as part of a group that gets handled together. And that is the way to think about things. And what that means is you can't be myopic and look just, you know what? The tea wasn't doing it. You were asking me about cheating on my almond milk with the tea. The tea wasn't doing it. We're switching to the almond milk. There it is. All right. Sorry for the interruption. It has to happen now and again. Anyway, what you need to do is stop looking at things in that myopic way that focuses on the individual creation and destruction of one resource and start thinking about creation and destruction and acquisition and releasing in waves. Now, you don't have to worry about that too much because we're going to be getting into those sorts of things a lot more later when we have a lot more resources to deal with. But right now, the reason that I wanted to bring it up is because what we're doing right here is we're creating this window. Now, we know that as long as our game is running, we are going to leave this window created. And if we ever do destroy it for any reason, we're going to recreate it right back again right immediately. And the reason is because we can't display our game without a window. So we know as long as the game's running, there's a window. When we exit this application, Windows will bulk clean up all of our windows, all of our handles, all of our memory. Everything gets cleaned up by Windows. So if we actually put in code that closes our window before we exit, we are wasting the user's time. I know it sounds strange to say it that way, but that is the truth. If you've ever had one of those applications where you try to close it and it takes a while to close down and you're like, what is going on? All I asked you to do is close. Well, honestly, a big cause of that is this sort of thing. It's thinking it has to go through and free all its resources manually and tidy everything up, when in reality, a lot of those things, if they had been thought about as in terms of waves, it would have closed like that. Just something to think about. Again, I apologize to object-oriented programmers out there who are having a fit right now. What can I say? I'm sorry, that's just not the way I code. All right. So, we are letting our window die. The reason I said there's a little bit of an oddity here is because we handled the WM close message and not the WM destroy message. We left the WM destroy message floating, sort of blowing in the breeze, if you will. And so if you want to be a little more appropriate or a little more clean here, you could do something like this, where you pass both of them. Or if you want to satisfy even the sort of try to tidy everything up sort of way of doing things, you could even call destroy window, which closes your window and kills it right here. Or you can do something even more pernicious, and it is probably honestly what I am going to recommend that we do, which is that we are going to instead talk about actually having a variable that controls the loop down at the bottom so that it will exit on its own. So basically what we're going to do here is inside our statement that used to be an infinite loop, we are basically just going to say while we are running. And this will give us a global Boolean flag that we can go ahead and kill anytime we want to. And we're going to talk about this in one quick second. But basically what we're going to do here, actually I'm going to initialize this in the way that I normally do. What we're going to do is we're basically going to have a giant a Boolean global that says whether we're still running, and when we go to close the app, or if our window gets destroyed for some reason, we are going to set it to false so that we exit. Now, in the future, we probably will not actually do these things directly. What we will probably do instead, and the reason that I'm setting up this Boolean here, is we will probably only really do this setting running to false somewhere else. We'll have to do it somewhere else. So for now, it's going to be a global, but in the future we may move it. So this is a global for now. And the reason I say that is because the user may try to close our application, and we may not want to actually close the application. We may want to pop up something inside the game that says, are you sure you want to exit, or something like that, in case they may lose progress in their game. If it's like some kind of a roguelike situation where we're not going to save it, we may need to do something there, so we probably want to exit here. And with WM destroy, that is what happens when our window gets destroyed. And honestly, we may want to treat that case as an error. Let's say our window gets destroyed somehow that we did not foresee. We may want to flag that and go try to recreate our window later. So I'm going to do both of these as well. And really, this whole structure is going to be largely placeholder code for when we come back a little later and handle this with a message, and or I should say to the user, and handle this as an error, recreate window. We will want to come in here when we do the second pass on the Windows platform later, which will be much later, when we're going through and tightening everything up and making it super good for shipping. We may want to do those things. All right, so let's talk about this global. I am not averse to global variables, but I am also not a huge fan of them either. The dogma that says you should never have a global variable, I certainly don't buy into, but there is a reason that dogma came about, and a lot of the points are pretty valid. Basically, something we'll be trying to do to avoid making mistakes is we will be trying to avoid having code that should not be touch those things, for lack of a better term. And so the more we can make our code very clear about what it can and can't access, the better. And that is where global variables really pose a problem, because since anyone can touch it at any time, it makes it rather difficult for us to see. So this is something that in our Windows code right now is totally harmless. It is just a thing that controls exiting from the loop. Our Windows code is always going to be a little bit janky because it is interfacing with Windows, and Windows is not designed particularly well. It's not a very good API. So I am not concerned about doing things like using globals in the Win32 platform layer. Most of our code will not be in that layer, and most of our code will not be touching anything that are global in there, to say the least. They will not even really know that it is there. So it is not really that big of a deal, but even so, I will probably move this out of globals at some point just so I can have a much clearer idea of exactly who can change running and when. So that said, watch for me talking a little bit more about globals in the future, because we will have some more things to say, possibly even on this very episode. But for now, we're going to go ahead and use them, because a lot of times you will use things as you lever code up into a working state, and then you sort of solidify it down, and you may start to pull things out that were global, or pull things that were in functions out of them, or those sorts of things, and that's what we're going to do. So we're going to have to go in here. We'll start running basically right before we go into our while loop, so we're going to set running equal to true. Now, one thing that you'll want to note is that static, we saw it once before. We used it in here, and this was to say that it persisted. Now, it's very confusing in C because static actually means different things depending on where you put it. It is not a particularly good keyword. And so one of the things that I actually like to do, and I'll start doing this right now, is to really define static into two different keywords, and I use the one that I actually mean. So if I have a local variable that is local persist, I will use that. And if I have a global variable, I will usually do something like this. There you go. So let's call them that, and let's actually put those in place. So instead of typing static, I just renamed that so we could see this is a locally persistent thing. It means that it stays around, but it is still locally scoped in here, right? Whereas this thing right here, this is a global variable, right? There you go. And now you can actually see what those are instead of looking at static, because static means two different things. In this case, what static meant was it meant that this value would stay the same after it exited this scope. So normally what would have happened is every time through the scope, it would have set it to whiteness again, because it would have been a local variable. If it looked like this, that's what it would do. But as soon as I declare it static, it means it actually allocates space to store it for now and ever. So it assigns whiteness to it the first time, but then immediately after that, it starts assigning other things to it, and those things will persist. The next time it comes through this code, it will not do this initializer. It will not do it. And so it will retain the value that it had. So when we wanted to do this kind of toggle, where we toggle things back and forth, that was a really kind of convenient way to do that. Now we're going to rip that out because I hate using local persist. In fact, one of the reasons that I do this exactly this way is so I can search for things, like all the times when I use static to do local persist, because I don't mind if they're global variables, but I do mind if there are these, and I like to be able to get rid of them. Now, if that weren't enough for you in terms of confusion, The other thing that static does, it has one more meaning. What it does is it basically can define a function as being local to the file that it's in. So it can be basically used to say, don't allow this function to be called from any other file other than the one that it is in. And by file, I actually mean translation unit, and that's actually going to be important in the future, but for now, you can just think of it as source file. But to be continued. And so usually what I will do is I will say something like internal or internal function, right? I usually just use internal. So, all right. That are some pound defines just to change the word static into something that we can actually remember and use a little bit better and search for, more importantly, when we need to clean up our code base. And so what I'm going to do now is I am going to say that, well, oh, I forgot the thing that I was going to tell you as well there, which is that the other thing that's interesting about static that it does automatically for you is that if you use static to declare a global variable, it is automatically initialized to 0. So if I were to type this or this, I would basically, because false always evaluates to 0, basically that is exactly the same as just not saying anything. I do not have to initialize it to 0. It is initialized to 0 by default if it is static. So there you go. Okay, so if we were to take a look at this now, we could go in here and, oops. Static macro redefinition. Oh, duh. That's good. This is the sort of thing that happens on a stream when you are too busy explaining things. You put your stuff in the wrong order. My apologies. Awesome. Yeah, there we go. So anyway, yeah, defines. Oh man, it is a sick day. So defines always go in this order. That is just completely, yeah. Hopefully everyone knew that already because I think we covered those. But just in case they didn't, pound define. Since I already made the mistake, I might as well have to explain it again. That is my penance. Pound define always takes the thing you are trying to define anew, and then takes the thing you want to be. So it translates this into this. And I had them reversed, which is absolutely no good. So there you go. All right. So if we take a look at this now, and we run this application, we can close our application by hitting the close button, and it closes just like we wanted to. And basically what will happen there is it will set running equal to false, and we will exit right out. And again, all we will do is basically let Windows clean up everything for us because it's going to do that whether we like it or not. And if it's going to do that, then we might as well let it. So we now have fixed the only problem that we actually had with our application, which is that you could not close it, and you can close it now. Very exciting. We still have two things to handle here, activate app and WM size, but we are going to get to those in a second. What we really need to focus on now is the fact that we can't really paint anything meaningful. Now basically what we have to do here, when we did our paint, you'll notice that what we had to do was use GDI to paint things. And GDI is Windows' graphics API. And like I said, we want to do everything from scratch, so we want to interface with GDI as little as possible. Basically what we want it to do is take a bitmap that we have already rendered using our own code and all of our own techniques and just display it to our window. In order to do that, we have to basically ask Windows to allocate a bitmap buffer for us that we can write into, something that's in a format that it is comfortable with us handing back to it. Then we will write into it and tell it to go ahead and display. Now, this involves a bunch of Windows stuff, and I wrote down all of the things that I wanted to remember to tell you, so I'm going to open my notebook here and hope that I don't. They're kind of a little scattershot in the notebook, but hopefully I'll remember them all as we go through it. So, here's what we're going to do. Let me give you the big picture. Basically what we are going to do is we are going to ask Windows at some point, and I'm going to go ahead and just kind of type these out here as functions. We are going to have a function that's basically called resize div section. And div section is the name. It's called DIB, device independent bitmap. That is actually the name that Windows uses to talk about things that you can write into as bitmaps that it can then display using GDI. Okay. We are going to have a function that basically resizes a div section or initializes it if it's never been created before. And basically what we will do is every time we get a WM size message which says that our Windows size has changed, we will basically call that. So we will basically force it to create an entirely new div section that is the correct size, so it is the size of the entire window. Now, we won't quite, probably, want to do exactly that, because since our game is going to be a 2D game and we will be wanting to render potentially at fixed resolutions, what we'll eventually probably do is only pick a size that is a reasonable size for our rendering that matches how we have done our source art. That also corresponds to roughly how big the window is, but for now, we can just go ahead and actually create it to be the full window size. And then once our game's renderer is up and running, we can start to think about those other things and control them. So what we will do here is we will call resize div section, and of course what we have to do in that call is we have to basically know what the actual size of the window is that we ended up with after WM size. And the way to do that is a thing called getClientRect. Now getClientRect is a very simple function. If you remember, we had some experience with rect before. It was right here, basically. It's a thing which basically says, here is a left, a top, a bottom, and a right. It is a lot like something you might see in HTML, like in CSS. It basically defines a rectangle on the screen. And oops, that's not where I wanted that at all. And basically what we're going to do is we're just going to go ahead and grab the rectangle for our window. And the reason that it's called getClientRect instead of something else like getWindowRect, which also exists, is this just gives us the part of our window that we actually can draw into. Because if you look at a window, so for example, let's say I go take Notepad over here, you can see that the actual part you can draw into is like in here, and then there's this like border frame thing, and that's actually all being handled by Windows, right? So there's not a whole lot we don't want to touch any of that, so we just want to know the size of the part that we can actually draw to, right? And now if we were full screen, when we go, because we're going to want to go full screen eventually, when we're full screen, that doesn't matter because there is no border around the window or anything like that. But until then, when we're using one that has a little border that you can resize, we have to take account for that. Or I should say, take that into account. Grammar. All right, so we are going to ask for the rectangle. You can see it takes an LP rect, and like I said, long pointer to a rect. That's that Hungarian notation coming back there. So we have our window rect, or I should say maybe our client rect, since the window rect is technically something else in Windows. It's the whole window, not just the area you can draw to. I am going to go ahead and get that out, and that will give us, just like we did down here, that will give us our width and our height. So basically we can just subtract the right from the left and the top from the bottom, sorry, the left from the right and the top from the bottom, saying that correctly. We are going to go ahead and do that to produce the width and the height of the buffer that we need to fill the whole window. That's basically how big we will need it to be. So we're going to go ahead and call resize div section, and excuse me, we are going to pass it that width and that height. So in here, we are going to get a width and a height, and we will basically need to build that buffer using Windows to give us a buffer that we can draw into. Then what we will do, once we have our div section sized properly, we will actually in Paint, instead of calling this patblit thing here, which is not really anything that we want to do, we will do the begin paint, and we will use the rectangle that it passes us to basically update that rectangle with whatever the contents of our buffer was. So we're basically going to create a buffer in WM size, because we always get that anytime the size of the window changes. We're going to create that buffer. We're going to draw to that buffer during our game loop. We're just going to keep drawing whatever the state of the game is into that buffer. And then anytime Windows needs us to repaint, we're going to blit from that buffer into the window. We're basically going to copy what's in our buffer, or rather we're going to ask Windows to do the copy, since this is the only thing that can actually write to the screen like that. We're going to ask it to copy from our buffer into the space occupied by our window. Now we will also be forcing redraws at, say, 30 frames a second in order to do animation. We will be force splitting, so we will not only be painting inside WM Paint, which is just a message we get when Windows thinks some part of our window is dirty, like it went off the screen and came back, or some other window was obscuring it and went away. So we won't only be painting in Paint, but it's one of the places we'll paint. Okay. How do we do that? Well, you know what? I'm going to make a stub function first. So inside here, in between our begin paint and our end paint, I am going to go ahead and say like update window, like this. And actually that I believe is actually a reserved Windows thing, so I probably can't call it update window. But that's actually okay, because you know what I like to do normally is I actually like to prefix my stuff with Win32 so that the platform layer, so it's clear what is Win32 stuff, and what isn't. So that's okay. We'll just call it that, and then our names won't collide with Windows names. Windows has a lot of names to collide with. Okay, so when we basically get our X, Y, width, and height here out of the rectangle that Windows asked us to repaint, we will go ahead and pass them, like this, to our update function. And of course, since now we actually will need the window handle because we're going to actually blit to the window, we're going to pass it that window handle as well so that it can update it. And then we are going to go ahead and erase this stuff here. So that got rid of our locally persist thing, which, like I said, I don't like and I wanted to get rid of. So we're going to now move this up here into an actual function. The function takes an hwind, right, the window handle. It takes the X and the Y that are going to be the upper corner of that thing. I prefer X, Y, width, and height instead of the top, left, bottom thing. That's just me. So I don't use the naming convention that Windows uses where it's right, left, top, bottom, etc. I use X, Y, width, and height. I just think it's a little clearer for me. It's easier for me to remember. And in here, we are going to update it. So what we actually want to do here is we are just going to call a function that is called, I believe, where is it? Let's see. So dib section. Can we get a dib section? There we go. Guess we should start by creating one. So we are going to have to call create dib section to get it. So we might as well start with that as well. We're going to need create dib section to ask Windows to make us one of these bitmaps. And we are also going to need the function to blit it, what is the best way? There's a couple ways. There's stretch DI bits to device, but that actually changes the scale. Which one did I use? I'm trying to remember which one I normally use. I guess stretch blit would be the right thing to use. So this is a quandary. So this is the one I was thinking of using. Stretch DI bits to device. Let's see. Or is it? I guess it's not even to device. I think it's just stretch DI bits. Yeah, there it is. Stretch DI bits. So this is the one that I was thinking of. And I'll tell you what that one is, and then we can maybe think about whether that's actually what we want. So what this one basically does is this one takes our dib section, the thing that I was saying we're gonna have to create, our device independent bitmap section, and it blits it, but it allows us to scale it at the time. And I was thinking that would be a good idea because then we could always render to the same size, and then we would just, scale it up to the size of the window. And I don't know, so that may be, you know what, I think that's probably what we're going to want to use in the end, so I'm going to just go ahead and use that one now and allow Windows to do scaling in there if we want it to in the future. I'm going to use another kill rectangle if people liked that in the previous stream. Kill rectangle is a fun thing to get rid of those specifiers. Okay, so I'm gonna actually start with that because I think that's what we're gonna want to use in the end, because basically, like I said, if we decide to use a fixed size buffer or a couple different fixed size buffers to do our rendering, and then we want Windows to kind of blow it up to the size of the window or shrink it down to the size of the window, depending on the circumstance, we're gonna need stretch DI bits. So I think I'm just gonna go with that. And if it turns out to be a bad call later, we will change it. All right, so all this function does, it's very, very straightforward. It is a rectangle to rectangle copy, and I'm going to explain coordinate systems a little bit later on. But basically for right now, if you could think about two rectangles, we're just going to copy one rectangle to the other. And in this particular case, the rectangles can be different sizes. So we're going to take a rectangle of one size in one buffer and copy it to a rectangle of another size in another buffer, doing scaling along the way if we need to. Oh, you know what? And here's one thing that I forgot. We don't really want the window here, do we? We want that device context, because we already had the device context right here. So rather than having to get the device context from the window, which we could do, let's just go ahead and pass that in there, because that's the thing that we actually have to pass to Windows. So there we go. There's our device context. So we will go ahead and put our device context in there, first parameter. Now we need the destination rectangle. So the destination X, the destination Y, the destination width, and the destination height. And basically that is some subsection of our window. So we are going to pass it basically the exact things that we got from RC Paint. So basically this is the rectangle that Windows wants us to fill, right? That is the part of the window that needs to get redrawn. So we're going to blit to that, basically, right? Then we basically have our source here. Our source, our X, Y, width, and height that we are blitting from. And since we are going to start by just making everything exactly the same size, our back buffer will be the same size as our window, this is exactly the same. We are basically having two buffers. One is our window that we're drawing to, and one is the buffer that we are actually drawing our stuff into with our renderer, and we are just going to copy one from the other exactly the same. So then we have to pass basically a pointer to the bits and a pointer to the bitmap info. We have to do some extra stuff here. You don't know what any of these things are yet because we haven't talked about them, and we're going to talk about them in a minute when we actually create the resize div section. But for now, I just want to look at these two additional parameters that control how stretch DI bits work. So let's take a look at MSDN again. Go down here. You can see that basically the usage tells you what kind of a picture this is that you have done, what kind of a buffer you have made. There are two kinds of buffers. One is palletized and one is RGB. Now, you all know what RGB colors are probably because you have all seen them before in a paint package or something similar. I'm going to bring up Color Cop, which by the way is a great free utility that everyone should have on their machine. I absolutely love it. But I'm just bringing it up because these little RGB things, or this little guy that you see in Windows all the time, or any kind of color picker like this, just shows an RGB color, which is basically 3 values from 0 to 255 that say how much red, how much green, and how much blue are in a particular color. We'll talk a lot more about colors much later in the series, but for now, you are all very familiar with that. Well, that is what this is. So if you want to make a backbuffer that is basically colors specified in that fashion, where every individual pixel has an RGB value, then you want to pass this, and that is what we're going to do. So we are going to put that in there. There we go. Okay. But I will quickly say what this is. What is a palette? A palette is if you would like to be more indirect. So let's say instead you would like to only use, say, 16 colors total, 0, 1, 2, 3, 4, 5, 6, and so on. And so what you want to write into your buffer, for example, are just numbers that correspond to some color, kind of like Pantone matching, or basically some paint chips where you've enabled them 0 through something, in this case 16 bits, so 0 through 65,000. Basically, you then have a palette which is specified in RGB per color, so per index color. So basically it's indirected one time, so you're basically saying the things that I actually put in this buffer just refer out essentially to another buffer that will tell you what the color is. And this was done back in the day to make things smaller. It's basically a way of compressing the size of the buffer, because since an RGB value is at least 3 8-bit values, one for R, one for G, one for B, that's 24 bits, you could get away with less by using an 8-bit or a 16-bit palletized mode, where you basically just use, say, 8 bits to say what color you're going to do, and then those 8 bits told you to look up in a table of colors that were specified as RGBs. You don't have to worry about that at all, because those days are kind of long gone, although they sometimes come back when you're doing things like texture compression. But fortunately for us, we don't have to deal with that. We can actually do direct RGB writing into our buffer, which is much, much more convenient. So finally, we have a raster okay. Too sick to talk today. Raster operation code. And the raster operation code is something that says what kind of bitwise operations you want to do. Now, if you remember from the intro stream, there are a lot of bitwise operations, things like XOR, things like AND, those sorts of stuff. And if we go look where it says they're documented in bitblit, you can see those here. And basically all this does is it says what to actually do to the destination. Now, all we wanted it to do, we didn't want it to do any fancy bit operations. We just want to basically overwrite the destination with the source. We just want to copy. And so what we're going to do is actually just use source copy, which is defined exactly as that. It is a numerical code that tells StretchBlit to go ahead and copy the thing directly. There you go. So that's really all we're going to do with StretchBlit. That will update our window for us. This will get a little more complicated as we start to handle other things. But all we really need to do now, if we want to update our window, is we've got to find a place to get these bits and the bitmap info from. And the way we're going to do that is through create div section. This is the part where we actually create the backbuffer, because obviously to put that backbuffer to the window, we have to actually make it in the first place. And you can see the things that are involved here. First, there is a bitmap info structure, and we'll talk about that, what that is. There is a hbitmap, which is a handle to a bitmap that it returns to us. So this is actually our bitmap handle that is coming back to us from create div section. Thank you, create div section, for that. We're going to need a device context, but you know what? That device context is not going to come from where you think it's going to come from. It's going to be a little bit bizarre, but we'll get to that. And then we're going to have to look at a couple of these other things here. We have some other things that we've got to specify. So let's go to the MSDN and check out what our options are. Create div section. Okay. Here we go in create div section. We have to get a device context, and I'll talk a little bit about where we're going to get that in a second. We have to pass pointer to a bitmap info, and that bitmap info is going to be something that we fill out. So this is an easy thing to do. We'll just go ahead and pass that, and we'll fill this out in a second. There we go. The iUsage parameter. So what is iUsage? Again, this is the exact same thing that it's asking us. When we created it, wants to know, is it going to be palletized or is it going to be RGB? And since we're blitting in RGB, we used RGB in stretch blit, we need to use RGB here as well, because that is what we wanted, right? Then we have a pointer to the bits. And so this is actually the big moment. This is the actual memory, this is the bitmap memory, that we are going to receive back from Windows that we can finally draw into with our own renderer. That is the big thing that we wanted. That's what we really wanted out of this whole platform layer, and that's what we're about to get finally, after 2 days. So, the H section, excuse me, is basically something that's used if you want to do something fancy with your div section. That's sort of doing it out of core and writing it into, I guess, into a file or something like this. We don't care about this stuff. We just want to allocate one in memory for us. We don't want it to back it with a file or do any of this stuff. I don't actually know if it does back it with a file. It may just actually use some kind of memory mapping for it. I don't know. I've never actually used this parameter, so I don't care at all about that. And we're not even going to spend any time on it because time is of the essence here on this stream. And finally, we have an offset, which is referencing this thing. So since we know that we're not passing this thing, and it's ignored if this is null, we can ignore that as well. So there is our create div section call. It will create the div section for us, and pretty much that does everything we want it to do, except we did not fill out the bitmap info that we are passing to it. So what on earth is a bitmap info? Again, this is all the vagaries of programming on Windows. It's a bit esoteric, and I don't blame you for going, what on earth is going on here? It's just the way it goes. Here we are on the bitmap info. So, we have a bitmap info header. It's called .bmi header, and we have an RGB quad, which is BMI colors. Now, this is a little syntax that's used in old school C, and then basically, if you define an array at the end of something, it allows you to make it variable length. You can basically keep on going off the end of this thing, accessor-wise. I'm not even going to begin to talk about that and how that works or anything like that, because we don't care about that right now, and I don't think you should really, I don't really recommend ever doing it either. But if you really care about it sometime in a Q&A, I will tell you what's going on there, because it's super janky and weird, but it works if you think about it. Anyway, we don't care about this because we are not using a palletized buffer. Like I said before, we are using RGB values, and we'll see how those work in just a little bit. Probably tomorrow's stream will be a lot about that. But anyway, this is basically where the palette goes. It's a variably sized array that will contain all of the colors that you plan to reference in your buffer. And since we don't plan to reference any colors, we plan to write the colors directly into the pixels where they belong. We don't have to worry about that at all. So BMI header is really the only thing that we need to know about, and because we are going to have to fill that out in order to specify what we want. So in here, you will see all of the things we have to specify. So BI size. It says the number of bytes required by the structure. So that's basically Windows asking us to put into the structure itself how big the structure actually is. Now that makes some sense probably because maybe they want us to include like this if we had one of them or whatever. Sometimes Windows just wants you to pass the size of things so they can tell what version of the API it was that called them. But basically what we need to do here is use that size of function that we saw before, where we can get the size of things. We saw that in the intro stream, to basically just find out the size of the structure itself. So hey, whatever the bitmap info structure is. Now, do they want the size? Which do they want the size of, ladies and gentlemen? Do they want the size of this, or do they want the size of this? That's the real question. Number of bytes required by the structure. It doesn't say. An application should use information stored in the BI size measure to locate the color table in a bitmap as structure. Oh, here is the clue we needed. It says the color table, which is I believe this right here. It says the color table is the thing that comes the BI size, yes, BI size after. So this is exactly what we want. Okay, so if you were in the intro stream, you remember us doing something exactly like this. We basically took a pointer we cast it to a char star, which is exactly what they're doing here. That is Windows #define for a char star. We casted a pointer to a char star, and we added a memory offset to it to get to a new place in memory. People who remember the stuff from the intro stream, you are very happy right now because that is exactly what you need to know. So now we know what that size parameter actually is. The size parameter is how big the header is so it can skip to the color table, which to me suggests that it should only be this size. It should only be this thing here, and it should not include the color table. So we're going to go ahead and use just the size of the header portion like that. Next field we need is the width. We know what the width is because that is getting called right here. We know what the height is, so that is right there. We know what the planes are because that is sort of an old school notion. Basically, bit planes used to be when you would specify multiple chunks of memory that get combined to give you the color. We don't have to do that anymore. Thankfully, all of the pixel RGB values are not stored in like a red plane, a green plane, a blue plane, or something where you have 1 bit per each part of the red value or anything like that. We don't have to worry about that, thankfully. Everything is actually per pixel packed together nowadays, and you can't even specify anything other than 1, apparently. It says this value must be set to 1. So we don't have to worry about that. We don't have planes. We only just have our backbuffer, so that's good. We'll talk a little bit more about these things when we decompress. Maybe on the Friday stream, when we go back over everything, I will talk a little bit about the history of some of those things for everyone. But for now, I want to keep going. The bit count is the number of bits per pixel. Now, 24 is actually how many we need. But I'm going to ask for 32 for reasons that will become clear in a little later. The reason I say 24 is because we need 8 bits for red, 8 bits for green, 8 bits for blue, just like you would see in, say, HTML or something like that. We want an 8-bit color for each for now. And I'm going to actually ask for 32 because I want things to be D-word aligned. But you don't have to worry about that just yet because we're going to talk about alignment totally separately. All right. And that will involve us opening up the Intel architecture manual, which is always fun, ladies and gentlemen. You will enjoy it, I promise you. So we can then say what kind of compression we want, and we do not want this compressed at all, because what we want to do is be able to write to it as fast as possible and blip from it as fast as possible. We do not want it to be doing any fancy compression, so it's going to be thinking about things at all, trying to compress them. We do not want that. So we're just going to pass BI-RGB for the format. Sorry, what was the actual format name? It is BI compression. BI compression. There we go. Size image. What on earth is that? The size in bytes of the image. This may set to be, oh yes, to be 0. So basically that's just going to, show up if you actually have a compression format where Windows wouldn't know how big the thing was going to be because you were going to do some compression on it. Pels per meter is sort of totally useless for us. Why would we need to know that at all? That is something is only if you were actually using some kind of print output. Pixels per meter, we don't even have anything about that. So can we set those to 0, ladies and gentlemen? Is there a way to set those to 0? I feel like they could both be set to 0. So I'm going to set them to 0 for now, hoping that it does not mind, because that is basically for printing and that sort of stuff where you have an actual, or something where you actually care about the physical size. We don't even know what the size is of our display at this point, so we're in no position to say how many pixels per meter there are on it, because we don't know anything about that. Clear used, the number of color indexes. Okay, this is how many colors are used in the color table. I just said we don't have a color table, so we don't care about that at all either. And finally, BI color important, also not care about because we do not have any of that indexed palette stuff. Okay, this should actually go through and allocate our bitmap memory for us, but we will not know until we actually try if we've done everything right. But I want to point out something that we now need to handle, and that is we actually need to free, well, we need to get our device context first, so we need to do that too, but we actually need to free this thing before we create a new one, because like I said before, if you go down here and you look at the WM size command, you will note that we basically have a resize deep section call will happen every time we WM size. So if we allocated new memory for our buffer every time, that would be bad. So what we actually want to do is just right before we create our new dib section, we could free the old dib section, or we can wait and see if we can get our new one first. And if we can't, we can keep using our old one. It's a tough decision. It is a tough decision, ladies and gentlemen, because basically there's a bunch of trade-offs either way, depending on how we do it. I am going to go ahead and say what we will actually do is we will we will actually free after. We'll create ours first and then free after. The reason that's a little touchy is because if we needed the memory from the first one in order to get the memory from the second one, because it was occupying too much memory, we would be kind of shooting ourselves in the foot. So maybe the other thing we could do is if it fails, yeah, this is hard. So you know what? We're going to put to do here, and we're going to say bulletproof this, and we're actually going to just do a free, straight up free first. So basically what we'll say is bulletproof this, maybe don't free first, free after, then free first if that fails. Maybe we'll give that a shot a little bit later just to be a little more resilient depending on these circumstances. Okay, so what we're going to do here is basically right here we will free it, free our div section, but then down here we will create a new one that we can then use to draw. So we're going to have to remember a couple things. As we can see down here, we need that bitmap info, which is this thing, right? So this guy is going to have to be persistent. So let's go ahead and put him out here, right? He's going to have to stick around forever. There you go. And now that will also clear him to 0. So that means all of these guys are cleared for us for free, right? Don't actually need to do any of that. Cleared for us for free out in the bitmap info. Then we've also got this bitmap memory right here, which is void star. And again, these global variables will probably not last long. We are going to make them unglobal in just a little bit. But for now, to keep things simple and to make sure that we are on time for the day, we are going to go ahead and use them because they are going to use sort of across multiple things that do not share a context that we can easily get to. But I'll show you a little trick for that a little bit later. And then finally, we are going to probably need that bitmap handle because without that bitmap handle, we would not be able to free it. So I'm going to store this as well. So there we go. And what I am going to do is I am going to say bitmap handle, global variable, there we go. I am going to say at the top of this, if we want to free our div section, basically what we're going to have to do is if we actually have our bitmap info initialized. And since this is the first thing we initialize, I'm going to go ahead and switch on that. I'm going to say if that's actually initialized, then we assume that we will have to actually get rid of this stuff. I don't know if bitmap handle actually is something I can test for as well. Let's take a look at that. What is that actually defined to be inside Windows? I don't know if that's the thing we can test on. Let's take a look. Bitmap, hbitmap. Type def, it is a handle. So I don't know if that'll come back as invalid handle value or what. That is a good question. Let's take a look at create div section and see what it says the return value is on failure, because I don't actually remember. There it is. It takes a little while in MSDN sometime. Okay, let's see. Return value succeeds. The return value of the handle, if the function fails, return value is null. Okay, so basically this will initialize to null, which is good, and we can also say if bitmap handle, that means we've got one, and so we will have to delete that bitmap handle. Now, GDI is a little wonky. The way that that works is basically when it creates a bitmap handle, which is going to actually track the memory for us as well, it actually deletes everything through the same call, if I remember correctly. So basically, you actually pass bitmap handles to delete object instead of something like delete bitmap, and it just figures out what type it was. So you can actually see here in the remarks actually tells us this, now that I'm looking at it. The system closes the handle to that memory when you later delete the dib by calling delete object function. So yeah, I guess basically, they just wanted to make only one delete call and you just pass everything to it, and it's an HGDI obj that it expects to get. So we may actually have to cast this if Windows wants us to pass it to it because basically we actually have a HBitmap and I don't think it's going to do that autocast for us, but we'll find out. In fact, let's just find out right now. No, it was fine. Okay, that's totally fine. Oh, and I also forgot here. These are all in the BMI header, right? These are all in the header that we're setting here because this actual bitmap info thing didn't have any actual stuff in it. So there we go. Okay, so we're going to go ahead and delete this object here. And there's another thing we're going to actually have to do in this case that'll happen in a second. But the other thing that we have to do now is figure out where we're going to get this device context. Because we have a device context, we need to actually go ahead and create a device context that we can actually use to create our div section. But what it's going to do with that device context is it's going to create a bitmap that's suitable for use with that device context. And so in order to do that, basically we have to first get a device context that is something we can use to blit to the screen, because that is what we're trying to do. And the way that we do that is we use a thing called getCompatibleDC, and we pass it 0. Now I know that's a little bit odd and probably a little confusing to everyone. This is again the vagaries of Windows, but basically what happens here is, sorry, release DC. Basically what happens here is we can ask Windows to give us back a device context that's compatible with something, right? And you can see if I actually pass it in here, and remember device contexts are the things that we use to draw in Windows. You can see that basically when we do create compatible DC, we pass it another HDC and say, hey, we need you to basically make something that we could use to draw in a way that's compatible with this other thing that we're trying to use. And that's important to us because basically we have something we want to draw into that we're going to try and blit to the screen. And so what we want to do is create a device context that's compatible with the screen's device context, even though we are not drawing with the screen's device context. I know it's crazy. I didn't make this stuff up. Fortunately, once we're done with it, we're going to be done with it. Oh no, the 5-minute warning. Well, it's good to know that the app is working. We may need a little more than 5 minutes. We may have to go into the Q&A today. That'd be sad, but we might need a little bit more just to get this to the point where we're actually blitting to the screen. But we're almost there. If we get a device context compatible with blitting to the screen, we can then use it, and we will want to actually, you know what? That's not entirely true. That's not entirely true. We want to just actually keep this around, is the thing. We want to actually keep this device context around, because why not, right? So we can actually create a compatible DC for this thing and leave it selected. I really wish that 5-minute warning wasn't up, because there's a bunch of stuff that we should probably explain here. I wonder if we have to break this into two. That would be sad, because we're so close. It's that moment of indecision. Do you go into the Q&A and do you finish it, or do you stop and wait? Well, I'll tell you what we'll do. We'll make a compromise. We'll make a slight compromise. What we will do is we will call create compatible DC here, and we'll actually create a DC that's compatible with something, basically compatible with the screen. So we'll actually call create compatible DC with 0 to make a device context that we can use, that we can keep. So instead of having to release it, we will just keep it. And this will be part of the package that we will eventually wrap up into a nice little thing that we can use for doing this stuff. So this is our bitmap device context that we can use from then on. And if we know that we have done our stuff before, we will not need to make it, because I believe we can just use the same one forever, and that should be fine. But we could also shut it down and create it anew each time. I don't know. We'll see in a second. Point being, we will probably end the stream here, because there is so much to talk about in here, so many new things that we did, that I think we really want to basically have, we want to have enough time to actually go through everything and talk about, sort of decompress a little bit all the stuff that I did. So I'm not going to blow through the Q&A. We're going to stop, and we're going to actually do real rendering tomorrow, because we've basically done almost all of the work for it. So tomorrow we can just start fresh and start drawing things right away, which seems like probably the better solution. So hopefully everyone's okay with that. We were almost there, but at the last minute, it was past. We grasped defeat from the jaws of victory, if you will. So, all right, I'm just going to clean up this. We changed the name of that to Win32 Resize Div Section. So now we have a thing where we actually do call in and we do resize our div section, but unfortunately we don't actually do anything with our div section, so that is not particularly exciting. Basically, what we have done now is we have made it so that when we go in to do our resize, we check to see whether or not we already have a bitmap handle. If we do have a bitmap handle, we need to delete that bitmap handle. So we go ahead and we do that. But if we do not have a bitmap handle, that means this is a time, well, you know, I can make this a little cleaner actually. Let's just say also if we don't have a bitmap device context, we will also create one of those. And we never probably need to free that one, I don't think. We'll have to double check later when we start to do testing whether we would have to change, create a new one. If someone unplugged a monitor and plugged a new one in and set to a different display resolution or something like that, we may have to, I don't know. So it's a good question as whether we should create a new one or not here. So I'm going to go ahead and put a to-do down here. should we recreate these under certain special circumstances? And we'll take a little bit, we'll take a closer look at that when we do the final stuff. We filled out our BMI header, we asked for our div section, and we should have gotten back our memory. So let's take a look and see if that actually worked. If it actually gave us the back buffer that we wanted. So we come in here, we hit the resize. Obviously, this is inside our WM size call. So we came in here, and we, by the way, you can always double click in here to move throughout the various parts of the stack. This is where we are in the stack right now. So basically, this is, in fact, and I'll just go ahead and step through it explicitly for you so you can see it. So basically what happens is we come in here, we get a WM size message, we get the size of the window by getting the client rect, and you can see the client rect in here. Right, there's the left, top, right, and bottom. We can turn out of hexadecimal display here and see that our window is 1424 by 729. A very interesting resolution indeed, but that is what Windows created us as. We didn't ask for anything in particular. You'll remember we said use default, so it did. There we go. There's our width and height. Oh, the Q&A begins now. We're in trouble. But like I said, we're going to call it for today anyway. So anyway, point being that we got our size correctly. You can see we actually did our math there, width and height. We go into the resize. We don't have a bitmap handle yet, so we don't need to delete object. We don't have a, oh, that's a bug right there. My bad. We wanted to do this if we don't have a bitmap device context, right? Because basically we want to create one if we don't have one. So we need to do basically this not equal to 0 if we do not have one. And the shorthand for that you can do also is just not that thing, right? So there we go. Okay. Glad we stepped through that. Caught an obvious bug right away. One nice part about stepping through your code is you get to catch some stupid mistakes that you will then have to go in and go, oh, yeah. So we go ahead and create one of those. Let's see if we got back something valid. We did. We are going to go ahead and fill out our structure. Let's take a look at that and make sure it looks like what we think it should look like before we go any further. There it is. Everything looks good. 32 bits per pixel, one plane. That is the size we wanted. This is the size of the bitmap info header, which looks good. And now we will see if we get a bitmap handle back. And we did. Let's see if we got our bitmap memory back. We got that too. So it looks like we have succeeded in getting our back buffer, but unfortunately, we are not actually going to be able to use it. Sorry about that. Unfortunately, we are, oops, still got that breakpoint in there. Let's get rid of that. Don't want to break every time we resize our window. So there is our window. It is resizing at the moment, and presumably it is actually doing what it's supposed to do, although we have to do some actual work in here or testing to see if that's true. We can also take a look in the, excuse me, we can also take a look here in the task manager by hitting Control-Shift-Escape, bring up the task manager. One thing that I like to do periodically, especially when I write something like that, that's going to be doing some kind of finicky things where it's like, oh, it sometimes wants to free this thing and sometimes it doesn't because it's doing something clever or thinks it's cool. I do a lot of things to double check to make sure that everything is kosher. And so one of the things that I want to look at is what our memory footprint looks like. So let's go ahead and see if we can find our application here. What did we call this? We called it Win32 Handmade. So there it is. We can see our working set right there, which is basically how much memory we are using at the time. And I am going to go ahead and go nuts with this to make sure that we are not leaking anything. And you can see that we do not appear to be. So that is good. If that number set was going up like crazy or something like that, then that means we would be leaking something, but it looks like we are in good shape. Okay, so I'm sorry we didn't quite get to draw into it. We did all the work to get it. It's kind of like, doing all the work and not getting paid, and that's a little disappointing. But the good news is tomorrow we will be able to start right away with drawing, and that is the fun stuff, ladies and gentlemen. That is the part where we actually start working on the game. So I'm going to go back and stick to our schedule, even though I really want to go do that. I'm going to stick to the schedule and say, let's open it up for Q&A. I will go ahead and start taking questions now. Let's see. Where are we? Stretch to bits take a pointer to the pixel data. You don't need to bother with create div section. Just allocate an array yourself. I do not believe that's actually true, S. Sylvan. Unfortunately, so you can't just allocate anything you want and pass it back to Windows. The reason for that is that it is going to be padded in a very specific way that is the way that Windows wants it to be for doing the blit. And it has to be associated with a particular bitmap handle. Basically, it's not as simple as that, is I guess the way I would say it. We'll look at this a little bit more, but here, see if you can... okay, so basically what happens here is this guy, when he allocates that, right, we are going to get back memory that Windows actually wanted us to use. And as far as I know, we cannot just willy-nilly decide to do it in a particular way. Maybe that's not true. If that's actually true that we don't have to have Windows do it, that would be pretty awesome. I mean, we could certainly try it. In fact, I guess since we're in the Q&A, we could totally try it. I don't know if you want me to if you want me to go nuts here, we could totally try it. I'm not optimistic that what you're saying is true, but I mean, we could test it. Now, the problem too is if we test it and it works, that doesn't actually mean that it's the right thing to ship. Because you never know, like maybe you need, I don't know, I'm torn. But you know what? It's pretty easy for us to test, so we could just test it. We could just go ahead and say, allocate the actual bits and then try to blit them and see if that works. Let's, you know what? I'm not going to actually do that. I'm going to see if there's any actual documentation here about where those bits have to come from, because it may actually tell us what the case is here. Let's find out. Okay. This function, do blah, blah, blah. See, I'm just worried. So here's I guess what I'll say. I'm pretty sure that we could, if we wanted to, pass it our own data that we created. And yes, it probably would allow us to paint to the screen. I'm just not sure it would paint to the screen quickly. It might go through basically a slow path, if that makes sense. I know I'm not explaining this very well, but basically, I thought you wanted Windows usually to allocate it in its own way, with its own layout and padding, so that you would basically guarantee that it knew it could be on the fast path, and it didn't have to do any weird stuff to make it happen. But maybe that's not true, and it's hard to figure out necessarily where I would look for that kind of thing in the documentation. Obviously, we cannot step into Windows and see. I've always done it by using create compatible DC and having it do it, but I'm not sure. I wonder if Raymond Chen has something to say about this, because that would be pretty awesome. Let's see what the rest of the chat. Does anyone else have an opinion on here? Let's see. I didn't stop the local recording. That's true. I'm no longer going to split them. I'm just going to do one and a half hour thing, and people can stop if in the middle. Let's see. Does anyone know? No. So it doesn't look like anyone has a definitive answer. I don't know. So let's say, as Sylvan, let's say that I will actually try to ask someone with Windows internals knowledge, and I will try to ask them. And if we can't ask them, then what I will do is we will just test both. We will just test both and see if there's any speed hit to either of them, and we can also try that on lots of different people's machines maybe, so that we can see whether it's something that's safe to ship or not. Because honestly, I just don't know. I don't think I've ever tried it without letting Windows allocate the memory itself, and I'm just a little bit nervous about it because I can't vouch for the fact that it will work. Does create compatible to C have to happen? And we will take a look at that. Okay. It's a good point, though. It's an excellent point. Thank you for bringing that up, because, hey, if that is the case, then we can just get rid of this part right here, of this piece of the code. We can just create the bitmap header, and we can allocate the memory ourselves, and off we go. So no harm, no foul. Let's take a look at the questions. I think we covered some of this. These are, will you be using sleep? Yes, we will. When we find that we complete the game loop in too quick a time and we want to yield back some time to the system so that we don't melt down the CPU, we will use sleep. Do, do, do. Also, could you go back through how you got Visual Studio to cooperate? Yes. For those of you who missed it on the earlier stream, if you are in a situation where Dev Studio is not cooperating with your build that you're using outside, what you type is you type devenv, and then you type the name of the executable you're trying to debug. So in this case, we put that in build, win32 handmade.exe was where it was. So if I just do that line, it will go through and it will open the exe and start a debugging session for us. That's all you have to do. There's no magic to it. And then once you do that, if you go into Tools, Options, and in here there's a Startup, and if you set at Startup to last loaded solution, you won't even have to do that anymore, because once you have one up, it'll just always bring that one back up again. So that's kind of handy. Are other windowing systems less crazy to work with? No. Honestly, no. The weird thing about all this is, honestly, it looks crazy, and it is crazy. I am never going to defend the design of the Windows API, because all we should have had to do is just say, we're a game, give us a backbuffer. And it should have, how many people write games with backbuffers? There were so many of those at the time. Nowadays, they use 3D graphics cards, but back then, everyone did it. And so it should have just been one thing. It was like, hey, guess what? You enter WinMain, and you make a call that's like, I'm a game. And it just sets everything up for you correctly. And there's so many reasons why operating systems should do that, because they would basically lead to far fewer bugs, because everyone who makes a game doesn't know all the minutiae of Windows. I don't know all the minutiae of Windows. No one who shipped a game ever knows all the minutiae of Windows. And so they will miss something or whatever that they were supposed to do to handle a certain key combination or something. And so it's just bad. So yeah, I'm not going to defend the design of the Windows API at all. It's bad news. But basically everything is bad news. I mean, you go write a game in HTML5, and it's a nightmare, the stuff that goes on there. Take a look at the audio API for that. It's awful. I mean, there's so many things wrong with most of these platforms that picking on Windows is not that productive, because while they are bad, in some ways they're almost less bad than some of the things that people have been making several decades later. And what's that excuse? In 20 years or whatever since the last major rev of the Win32 API, what's the excuse, people? I mean, things should be really clean nowadays, and they aren't. And so I don't really, I whine about Windows certainly because I don't like using it any more than anyone else. But at the end of the day, it's no worse, and even sometimes better a lot of times, than some of the newer stuff. And that is frankly just depressing, because I would rather live in a world where operating systems were getting easier to work with every day, not harder. And what's funny about that is even Windows itself is also getting harder to work with every day, because they've started revving their API in ways that make it worse, which is crazy. So I don't know. That's why I'm still using a lot of the old school functions too, is because, man, the new functions are even more ridiculous. Let's see. This isn't entirely related today, but are you going to do a more detailed Intro to C series alongside this? Yes, I would like to do that someday. The only problem is my voice. I don't know how much voice I got in me if I start trying to do other stuff in parallel with this. Maybe we could take a week off and do a more detailed Intro to Series C, but probably have to be, to do a real Intro to C, it might have to be a couple weeks, and I don't know when we're going to have time to do that. So it's a good question. I would say watch the regular Intro to C one and do a lot of reading on the side, like read K&R, the C programming language, or just practice, in any programming language really, just practice programming if you're unfamiliar with it, and read up about C. It shouldn't be that hard to sort of get into most of it, because the stuff that I do in the Intro to C is all sort of showing you how it all ties together, like, looking at memory and looking at those sorts of things that are the sorts of things that people aren't used to doing if they're working in languages that aren't low level like C is. And so I think that maybe, I hope that people will be able to educate themselves about C a little bit if they're used to some other programming language in the meantime now. But yes, I would like to do a real beginner's Intro to C where we take it real slow and go through absolutely everything. But I don't know when realistically I will be able to do that, because there's only so much I can record without my voice going. Let's see. Can you explain what exactly is a void star, a pointer to nothing? Yes, I can, and we will get to that a little bit more detail when we actually start to draw. The reason it was a void star was actually because we don't want to specify the type that we're pointing to. So if you remember, a pointer is just a value that says a number, which is the offset in memory where something is, right? And so if I actually, yeah, someone was saying I forgot to move Chrome to the side. We need to like just dock Chrome on the side there, I guess, or something, and leave it there so people can look at the code at the same time. I got to learn to do that. People have been asking for that, and I should do that. But anyway, if we go in here and take a look, which we should do, if we take a look at that void star, this is a pretty interesting thing that happened here, so let's talk about it. Basically, we've got a situation where we want Windows to give us back some bitmap memory, basically, right? And that bitmap memory, it doesn't know the format of the bitmap memory, because remember, we pass stuff like what kind of compression to use and whether it was palletized or not, and so the function create div section can only have one function signature. C does not allow you to say stuff like this one function could take an unsigned short star, or an unsigned int star, or an unsigned char star, so allow those three, and blah, 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 right? You can't do that. The only thing C can do is use void star, and what void star means is some kind of pointer. It says, I want a pointer, but I don't care what it points to, so anything is fine, right? And so basically what we're doing when we say void star is saying we're going to get back a pointer, but we don't actually know the, the format of the thing to which it is pointing. And later what we'll do is we'll cast it to the format that we actually want to use at the time. And because this is a bitmap that we're going to be jumping through and writing to in different ways, we will probably actually cast it to more than one thing, depending on the circumstance. We will cast it to a char star, which is an 8-bit value pointer to an 8-bit value when we want to move around in it to find a location in it so that we can do arithmetic on it. And then we will probably cast it to a unsigned int, which is a 32-bit value, when we actually want to poke at the individual values, because that will allow us to write the RGB and A values, which is actually RGB and X values, but whatever. We're going to write those directly as one chunk probably. And we'll even do some more stuff that's even crazier later probably. But point being, that is what a void star is. So what happens in here when we call create div section is you'll notice we're not just passing a void star. We're not passing a pointer to bitmap memory. We're passing a pointer to the pointer to bitmap memory, right? Because right here, you can see I use the address operator to take the address of the bitmap memory. So basically what's happening is if you go into the debugger, if I run to that line, right, here we are about to call create div section, you can basically see that bitmap memory is just all zeros, and I am passing address of bitmap memory, right? So I am passing it the address of the pointer that I would like Windows to then go overwrite with the new pointer that points to the memory that it allocated. And this is a very standard trick that people do in C all the time. Basically what it boils down to is you have a function and you want to return more than one value from it, right? And that's exactly what happened here, right? Create div section needs to be able to return a bitmap handle, but it basically also needs to be able to return this bitmap memory. So I wouldn't necessarily do it this way, but the way that a lot of people do it is they just pass in the address of more memory, like more variables. They take the address of them and say, here's where I want you to stick those other return values that you couldn't stick on the stack because C only lets you have one return value. Now, the reason I say I wouldn't necessarily do it that way is because C really does let you do multiple return values. It lets you do multiple return values like this, struct create div section result. And this is how I probably would have done it. Now granted, this is an API barrier that has some certain requirements about it, so I'm not necessarily going to fault the Windows people for not doing it this way because there's other reasons at play there. But if this was internal to our own code, let's say, I would probably not do it that way. I would put the bitmap result in here, let's say, and I would put the memory result. So here is the memory. And actually, this was called, I think this is a handle, I should say, right? And then what I would do is when I define create div section, I would define it to work like this. So basically in here, we pass the device context, we pass the bitmap info, we pass the usage code, and we pass the other stuff here and here, but we never pass the address to bitmap memory, because basically what happens is create div section will return a struct that has both things in it. I like that way better, personally. And there's really no reason not to do it because C does let you return structures by value. and that is the way that I prefer to return multiple things so that it's clearer and no one's taking addresses of things and so on. Now, there can be performance problems with this potentially, so you don't want to necessarily do this if this thing was going to be huge for some reason. But if it's only 2 values, for all I know, this actually might be more efficient. It depends on the circumstances, right? So basically, I would say that this is a pretty sane way to do 2 small return values. I would rather do it this way than do it the way that they did. Okay, we're back to yes. Looking at the questions. I'm sorry I can't get to everyone's questions. At this point, there are so many viewers on the stream. That is both a blessing and a curse. It is so nice to see so many people on the stream, but it does mean that in 30 minutes, I'm just randomly picking questions. And maybe we're going to have to do something someday where somebody who, some kind soul out there will basically watch the questions and try to select the most interesting ones or something. I'm just basically randomly picking what I happen to see. Let's see. Any new thoughts on IamGUI since you made that video a few years ago? I assume the UI in this game will be IM. I am the person who actually coined that phrase. It is true, and I made that weird little video, and it seems like it's been something that's a little bit more popular nowadays. However, we are not going to get to that till a little bit later on. We are going to probably do some IM stuff. Actually, I shouldn't say probably. We almost certainly will, in the course of the stream, deal with IamGUI-like things, and I will actually, for the first time, talk a little bit about the philosophy of IamGUI later on in these streams, because I never really did a good job of explaining to people how IamGUI really was supposed to work, and when I go look at a lot of IamGUI discussions, while I'm very glad to see that the technique caught on, because I think it's good, a lot of them tend to miss the point a little bit. And that is my fault for doing a bad job explaining it, and it was probably also because I did that video pretty early on in my understanding of how IamGUI should work. And so I should probably set that record straight, and I will do that sometime during this series. And that will be a lot of fun. I look forward to it. So S. Sylvan follows up. He says, after a cursory glance at the stretch.gi bit source, it looks like at the stretch.gi source. Are you a Microsoft person? That is pretty awesome if you can look at the source. It looks like it's fine to pass your own buffer. However, if it's not dword aligned, it'll make a local copy. That's fine because we could easily ensure that it was dword aligned. That would be great. That would be great. We're going to put a to-do based on S. Sylvan's. You know, I got to say, this is a great thing about doing public programming. I mean, you don't have someone who can check the Windows source for you just right off the bat like that. That's crazy. Based on S. Sylvan's suggestion, maybe we can just allocate this ourselves. And that would be great because that would remove this right here. We could get rid of, this would turn into a memory allocation, and we could get rid of this entirely. That would be fantastic. S. Sylvan, thank you very much for doing that. We will test it. I appreciate the fact that, yes, he's saying it's complicated code and he didn't look at it that carefully, so maybe that's not true. We don't know yet, but you know what? Programming is always an exploration. I never know everything that's going on. That should be totally obvious, and neither does any other programmer out there that I know. Basically, you are always exploring. That's one of the reasons that I like the idea that this game is also going to be about exploration, because that is what programming is about. There's always more to learn. And so, you know, this will be a learning experience. I've shipped so much code in my lifetime that actually always asks Windows for this memory, and now if it turns out that you don't have to do that, that is awesome. That's just something that I don't have to do anymore, and it's kind of cool. That's good. That'd be great. So we'll find out. Let's see. When will the source be up for download? It's always up for download right after the video, pretty much. I push it pretty much immediately. So if you download, say, like an hour after the video ends, you will get this source. Let's see. What else we got? When using Emacs, I find it hard to use meta key with F and B to skip words. How do you do it so fast? I use the bindings that I have in my .emacs file, which is hold down Control, and use the arrow keys. Much, much better. How come that not equal to 0 is true in C and the return values from main and functions is 0 if everything is okay? Yeah, that's a darn good question. All right, so basically the way things work in C is defined as saying that something is true if it is not 0 and it is false if it is 0. And I think that's a great idea. That is the way it should work. I have no complaints about that. However, what did happen with the C runtime library, and which has been picked up by a lot of people, not their fault, they're just trying to be compatible with the C runtime library, is a lot of times they will do something where they will do the thing, like this. They define a function, and then there is an integer that is going to come back, and that integer is the error code. So the error code is 0 if there is no error, right? And then in here, if something went wrong with what we did, the error code becomes, let's say, -2, or if some other thing went wrong, then the error code becomes 12, and there's a table of error codes, and you can check them. That is what often happens. And the reason they're doing that is so that they can snuggle a little bit of information in there that's not just whether the thing succeeded, but whether it succeeded, but whether it failed in a particular way, if you will. And so the reason that that's kind of confusing is because now when you're out in the code, and this is what the question was addressing, if I do something like result equals do the thing, like this, and then I do if result, that looks like I'm testing to see whether do the thing succeeded, but it's not. It's actually testing whether it failed. Because if it succeeded, it'll be 0, and if it failed, it'll be something else. So you have to test that, which looks bizarre and is not the way you would test anything else. For example, if you wanted to know if a pointer was null, it would be the other way around. It would be that way. So it leads to confusion. I try never to do this. I try to handle error codes in a different way. But what can you do? That is just the way that some people program, and it is the way the C runtime library programs, and you have to be aware of it. It's also how Berkeley sockets work, I believe. So if you're using like a socket library, it tends to work that way. It's just there's a lot of things that work that way, and not much you can do about it. Let's see. Pre-ANSI C didn't allow return structs. So that's, oh, is that Sean Barrett? That would be fabulous if Sean Barrett was here. Sean Barrett is, for those of you who do not know him, he is a pretty storied programmer, actually. In fact, the thing that you would probably most recognize of his is he wrote the renderer. And again, this is in the days when there was no 3D hardware. So he wrote from scratch the 3D renderer for Thief the Dark project, which is a very famous game, and of course is a lineage that still exists. They still ship Thief games to this day. Obviously, they use GPUs and all kinds of crazy stuff now, but he is the fellow who wrote that renderer, and a excellent programmer. He wrote the STB libraries as well, which are things that everyone should take a look at. I again am teaching something where I program everything from scratch, so I won't be using them. But when you are looking around to see what libraries are available, once you are comfortable with stuff and can make good decisions about what to use, those are some ones to look at. They do a lot of great stuff in a very concise way, compact way that doesn't create headaches for you, which is what a lot of libraries do. So yes. Anyway, thank you very much for watching, Sean. And basically what I would say is I know almost nothing about pre-ANSI C, and Sean is telling us that pre-ANSI C didn't allow return structs. So that thing that I showed would not have been allowed way, way back when, like several decades ago before the ANSI standard standardized C. And so maybe that explains why that didn't catch on initially, because people couldn't do it, and then later when it became possible to do it, maybe people didn't rethink how they might do return values when they had multiple things, because that wasn't possible. So that's a pretty interesting thing. Obviously, I think I've always programmed in things that supported ANSI C, so I don't know that I've ever had to wrangle with that, but I don't know. It could be that sometime way back when I was doing it. But that's something I've started doing relatively recently, probably in the last 15 years or so anyway. Let's see. any reason you put the type in the line above the function name. It is a force of habit, probably not a fantastic habit, but I just like to separate the two out so I can see what the type is there. I don't know why I do it. I started doing it back when I used to be a absolutely crazy C++ programmer. One of the funny things about doing stuff like this, where I show kind of the old school dirty style of programming where you just get in and you do the code, is that I get sometimes mail, obviously, from people who are livid at the fact that I am not using all kinds of crazy C++isms like RAII or like templates or the standard template library. And the hilarious thing about it is I think they think that I've never used those things, but that is not the case. I used to use all of those things. And my code was a mess with them. They were everywhere, and I actually liked them at the time. What can I say? I've learned that I do not like the way that code comes out when you do those things, but I used to use that stuff a lot. And one of the things that is true when you have crazy templates and all this other sorts of stuff, you end up with things where you have like a template line with a ton of stuff and some return values and then all this stuff. And my functions were getting out to be these huge things that were just absurd, and the way I have my stuff set up to highlight is the parameters kind of keep that alignment there. There was like no room for my stuff, and so I think that's basically when I started. I would break the template line plus the type onto one line, and the function name and parameters onto the next one like that. So, all right, with that, our stream is now over, ladies and gentlemen. I am truly sorry that we did not quite get. We were so close. If S. Sylvan had I guess if S. Sylvan and I had been friends and we had talked about this quite some time ago, and I had known that I don't have to do that, then I would not have been shy, because I could have just allocated here and I wouldn't have been like, oh, I got to start talking to you about what a create compatible DC is. Now we can actually just get rid of that entirely, potentially. So thank you, S. Sylvan. You almost saved the day. You certainly did add quite a bit to the stream, but unfortunately, like I said, I don't check during the chat because I want you to see me make those mistakes and see how that goes. Also, I think it's good to see me make mistakes, because that way people know that programmers who have been programming for a long time make a ton of mistakes, because you will make a ton of mistakes and you will feel like you are just stupid or something. You are not, or you are, and we are all as well. Either we're all stupid or nobody's stupid, one or the other. But the point is, a lot of mistakes are made, and certainly a lot of them are made by me. And so I want you to see those, so I apologize for that fact, but I just think it's a good way to run the stream. So anyway, S. Sylvan, thank you for that. I'm sorry that I did not happen to check it before, but that meant we missed a little bit what we wanted to do, which was just draw a little something to the bitmap so that we could see that it was working. But what we will do is we'll pick that up tomorrow, and then we will have an entire 60 minutes where we can do nothing but draw to our bitmap, and I think that will be pretty awesome anyway. So it's a really good place to break, even though I was hoping we would get a little bit further. Thank you so much for joining me. It's an absolute pleasure, as it always is. I'm sorry that I was sick. I wish that I wasn't, obviously, and hopefully I will recover soon so that I will not make weird, delirious mistakes when coding. And also, if anyone has any additional questions that they would like covered perhaps on the next round, tomorrow night stream, you can go to handmadehero.org, and there is an email a question button. Also, I would like to remind everyone that Twitch is now also temporarily archiving these streams. So in addition to the archive button that you can push to get to the YouTube ones which I upload, those take a little while for YouTube to process, which means that sometimes you can't get to them right after the stream ends. So if you want to, you can go to Twitch, and Twitch will actually have on here, no, don't start streaming me for reals. It will actually have a little thing where you can go to past broadcasts. I believe you just click on the Handmade Hero button there, and you click on past broadcasts, and you can grab streams even before they've ended, it looks like, maybe. I don't actually know how this works, to be honest with you. But point being, if you want to start watching right away and not wait for YouTube, that's actually an option that you have. Now, these won't stay around forever. Twitch clears them out after about a couple of weeks, I think. So you need to use those archives for getting the older episodes, but that will be another tool you can use if you want to get things right away. I think that's it for tonight. Thank you so much for joining us. And tomorrow, it's going to be a new day, ladies and gentlemen. We're going to actually be drawing stuff to the screen. I'll be honest with you, I'm pretty excited about it. So please tune in tomorrow, 8 p.m. and we will do some rendering, finally. I can't wait. Thanks, everyone, for joining us, and I will see you tomorrow.